All right, guys, today we are looking at what are called sinusoidal models. And basically, these are situations that we are able to model using a sine equation. And as we have now learned, if I have a sine equation, I could also write that same graph as a cosine equation. So these are going to be application problems where we're going to use a sine or cosine equation to model the problem. All right, so for starters, we're going to start, by drawing a picture. And guys, these are rough sketches. They don't have to be as detailed as what we were doing before. And we're looking for particular information to help us with our graph. So we're going to have a max, a min maybe, might get both, we might only get one or the other. They're definitely going to tell us something about the period. Lots of times we'll start on the y-axis, okay? We'll start at 0, but sometimes there'll be a phase shift. And then we're going to sketch about one period of the function. We're then going to use that graph to take what we did in our last lesson and write a function. We're going to write an equation, either sine or cosine. And then we're going to use that equation to answer the rest of the problems. All right, so let's look at our first example here. We have a tide problem. And it says at high tide, the ocean generally reaches the 5-foot mark on a retaining wall. Well, high tide to me, that means maximum. So we've got our maximum. Then it says at low tide, the water reaches the 1-foot mark. So low means our minimum. And then it says that high tide occurs at noon and midnight, and low tide occurs at 6 p.m. and 6 a.m. All right, so we have enough information here, not really a picture to draw. We can go straight to the graph. We've got everything we need. So when I'm looking at this one, the first thing I have to do, because they didn't do it for me, is I have to define what the numbers on the x-axis mean. So I'm going to start by saying let t equal 0. And guys, we're going to use t a lot instead of x because we're actually talking about time. So you'll see that quite a bit here. Let t equal 0 be, and I'm going to let it be 12 a.m. because that just makes sense to me. Okay, so right here at 0, the y-axis, that's t equals 0. We know something about 6 hours after that, which would be 6 a.m. And then noon would be 12. And then 6 p.m. would be 18. Okay, we also have our minimum value of 1 and our maximum of 5. And we always know the midline is halfway in between. We're going to need that value, and it is 3. Okay, so now we're going to plot our points here. We know that at midnight and noon, high tide occurs, which is 5. So I'm going to plot points at 0, 5, and 12, 5. And low tide occurs at 6 a.m., so that's 6, 1, and at 6 p.m., so that's 18, 1. So we actually have more than one period here. And then it would continue. Okay. All right, so we have what we need here to write an equation. So for starters, if we think about it, right, there's my midline. That's D. So we know that D is equal to 3. All right, we also already know A. A is the distance from the midline to the max or min. That's 2. Now, the period, right, we're going to use that to help us find B. So if we're looking at this, remember we're using radians only. Parent graph is 2 pi for its period. This one goes from 0 to 12. So the period is 12 hours. So we're going to divide by 12 and we get pi over 6, and that is our B. And then phase shift here, well, I'm starting at 0. So I want to use this one right here. I'm going to use a cosine curve because it starts at 0. Okay, I could write other equations, but this one seems to be the easiest. So we're going to have y is equal to 2 times the cosine of b is pi over 6. And then instead of x, I'm using t. And then we have a vertical shift up 3. Okay, so that is part A here. We have graphed this and written a function to show how the height of the water varies over time. All right, now next it says determine the height of the water at 2:30 p.m. So think about this, 2:30 p.m., that's 2.5 hours past noon, which means this is t is equal to 14.5. Okay, and we're going to look at that in just a second. And then part C says determine the first time after 6 p.m. And 6 p.m., remember that's t equals 18, that the tide will reach the 4-foot mark. All right, so on this next slide, I have graphs that are representing both of these. And this is where what we did in class today with our, reviewing of graph skills is going to help us. All right, so on this first one right here, make this a bit bigger. Okay, we have the value right here. This is when t is equal to 14.5. Okay, and I put it in my calculator. I graphed my equation up here. Here's my equation, right, that we just came up with. And then I asked it to find the value at 14.5. And we get 3.5176, right? This is our answer here. Now, put it into context. We're talking about feet. So this is going to be 3.518 feet. We'll go to 3 decimal places. Okay, and again, I found that by plugging into my calculator the equation and then asking it to find the value. You could also just plug in 14.5 for x and evaluate it regularly. I did it graphically. All right, now the second piece asks me, when is the first time after 6 p.m. that our height of the water, is going to be 4 feet. So what I did here was a horizontal line. This is the equation for y equals 4. And then here at 18 hours, that's 6 p.m. So the first time that the water reaches that mark will be right here. Okay, and I did a point of intersection, and that point of intersection said it will be at 22 hours past midnight. That is the first time after 6 p.m. that the height of the water is 4 feet. Okay, so think about what that is, right? 22 hours past. Well, that's 2 hours short of a full day. So we are looking at 10 p.m. Okay, so now let's look at our next problem here. Make that a little smaller again. All right, so Ferris wheel problem. We see a lot of these Ferris wheel problems. It says there is a Ferris wheel every year at the North Georgia Fair. This year, the wheel has a radius of 33.2 feet. Okay, important information there. And makes a complete revolution every 15 seconds. All right, so first off, let's just talk about this. That's absolutely crazy. Don't get on a Ferris wheel that can go around in 15 seconds. It's actually this high. Anyways, we're still going to work the problem as it is. So 1 revolution, guys, that's a period, right? That's 1 time around the circle. So we have our period, it's 15 seconds. We have the radius, and then it tells us that the bottom of the Ferris wheel is 4 feet above the ground. So that's like the minimum. If we're talking about the height of the Ferris wheel, that's the minimum. It's 4 feet off the ground. All right, so when we look at this one and we go to write our equation and we do our sketch, let's think about the Ferris wheel, okay? So here's the Ferris wheel. Here's where you get on. Here's the ground. This distance right here is 4 feet off the ground. Okay, so the minimum is 4. Then when you think about a circle, right, we have our radius here, and it told us that the radius of this circle, let me go back because now I don't remember what it was, is 33.2. Okay, so our radius here is 33.2. Okay, and then that means, right, here's my other radius, also 33.2. So think about this as we go to actually graph our curve now. If we start at 4 feet, then we're going to add 33.2 on, and we're going to add 33.2 on again. So when I look at graphing this, okay, starting with my y values, the minimum is 4. Then I'm going to go up 33.2, and that's the center of my Ferris wheel. That's the middle of my graph, or the midline. That is at 37.2. And then I'm going to go up 33.2 higher. This will be the top of my Ferris wheel. And if I add, I get 70.4. Okay, then the next thing they said is it makes a revolution every 15 seconds. So at 15 seconds, I will have made a full revolution. Okay, so you get on the Ferris wheel at the bottom. So think about this. We get on at the bottom. We're going to come back to where we were, a full revolution 15 seconds later, which means halfway in between at 7.5 seconds, we should be reaching the top at 70.4. right? Just keeping everything in perfect ratio. All right, so if we go to write our equation here, here's our midline of 37.2, that's D. A is the distance from the midline to the max or the midline to the min. That's 33.2, okay? Notice, guys, A is the radius. All right, and then normal period is 2 pi. We're going to divide it by the period of this graph, which is 15. Okay, the period is 15 seconds. So our equation is going to be 33.2 times the cosine of 2 pi over 15t, and then we're going to add 37.2. Okay, now the only other thing, look at what we're doing here. We're starting at the minimum, okay, starting at the minimum, which means we need a negative out front here. So we've got negative 33.2 times the cosine of 2 pi over 15t plus 37.2. All right, now let's go back and look at our other questions. Okay, first one, it's saying how far above the ground the passenger is 52 seconds into the ride. And the other one wants to know how many seconds the passenger has been on the ride when he first reaches the height of 27 feet. All right, so let's look at the graphs that model these. And again, I've already put these into my graphing calculator. Okay, there's my equation up here, the equation we just found. Okay, and I want to know how high is the passenger at time 52 seconds. Right, and we see right here, this is the height, represented by this point up here. Not quite the maximum, but almost. So this one is 69.675 seconds. That is the height of the passenger at 52, feet, guys. That should be feet. Okay, that is the height of the passenger at 52 seconds. All right, now the other one, similar to the other problem we just did, okay, this one says, what is the first time they reach a height of 27 feet? So as soon as the Ferris wheel starts to lift, this line right here is y equals 27. So when do we first hit that 27-foot mark? And that is represented by this point right here. Okay, so by doing a point of intersection, we figure out that at x equals 3.004, or in our case, t equals 3.004 seconds, we will be at a height of 27 feet. Okay, so the answer to part C is 3.004 seconds. Okay, we're going to spend a few days on this so we can get it down. And just remember, take it just step by step, look for those mins, max, and the period, and go from there.